Okay, good evening or good morning or good afternoon, whichever time you're listening to this audio or this video slide explanation for the IT Essentials Module 3. Okay, we looked at Module 1. I'll look at the components of computer. We looked at Module 2, where we looked at a little bit of some advanced. I talked about assembly of our components. How do we assemble? How do we put up everything together? How do we understand all of the components or understand the things that we need to actually clone our systems? Now, in Module 3, we're going to be looking at some advanced computer hardware. Okay, so these are planning guides. The module actually starts from here. Then these are some of the things that are the objectives for the class. And it actually starts from 3.1. Okay, boot the computer. What happens when you boot the computer? So you have a video demonstration in your LMS. Please make sure you get to your LMS and watch that video demonstration. It tells you your BIOS, your UEFI menus, all of the things you see when your computer starts up, and the main screen, the settings, the OC, the M flash, the OC profile, and the hardware monitor, your board explorer. It shows you all of those things that happens between your boot time and when you get to your Windows desktop. So we explain the entire process. So we have what they call post power on self-test. So that's what it's called. So it then means that every computer, before it starts functioning, have to do a self-test of each of the components you have within it. The motherboard, the power pack, the processor, the RAM. It tests everything. If everything is okay, you're good to go. It moves to the next stage. If something is not right, it throws up an error message for you. It tells you, okay, this is wrong, this is wrong, this is wrong. You have to do this. It throws up an error message, or it gives a beep sound. So that alerts the technician. You hear things like ping, 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 or ping, ping, or ping, ping, ping. So different manufacturers have different beep codes for different kind of error messages or different confirmation messages. Some messages are not as a result of there's a problem. Some messages are as a result of you having passed the test. When a computer is booted, the basic input output system that the BIOS performs a hardware check. That check is called post power self-test. If the device is functioning, an error or a beep code alerts the technician of the problem. BIOS manufacturers use different codes. Ah, these days when you have a laptop comes up, you have less of that. uh, Laptops don't really use, rather the laptops normally use maybe flashing lights. A few times you can have codes, you can have beeps, but most of the times you have the keyboard lights flashing maybe on any of the function keys, or you have your power and your battery, your hard disk activity button maybe flashing wherever. So what do you need to do? If it's a desktop, if it's a laptop, all you just need to do, or if you hear a sound, so you have different types of sound or different types of beep. So if you hear something like ping ping, so that is two short beeps. So you're asking yourself, or you're asking Google, or you're asking the manufacturer of that motherboard, Toshiba Satellite 25710 on boot up makes two short beep. If you put that on Google, it takes you to the manufacturer site and it tell you what that means. You don't need to cram, but you don't need to memorize all of the beep codes and what they all mean. No, you just need to understand and be able to translate the error, the issue that you have, so that you can now find what the issue is. But there are some standards, and in the course of the training, you're going to know some of these standards. And but there are some that are not properly documented, but you're going to have them on the manufacturer site. So always consult your motherboard documentation to get the beep codes for your computer. So you have different beep codes for different computers. Installation tip. To determine if post is working functional properly, remove all the RAM modules from the computer and parent on. The computer should emit the beep code for a computer with no RAM sound, with no RAM installed. So if you don't have RAM, it's going to give you a different beep. If you don't have processor, it's going to give you a beep code. If you don't have video card, it's going to give you a beep code. This will not harm your computer. You're just learning, you're just troubleshooting, right? Okay, so we have what they call the CMOS. So I think we'll show you what the CMOS battery looks like. So all motherboards needs a BIOS to operate, or BIOS is a ROM chip on the motherboard that state scan. If it's bad, the system will never boot. I repeat that again. If it's bad, you gotta replace this or you get a new board entirely if it's corrupted. Why? That is the main guy. That's the guy that does the first. I have a laptop in the office that have a corrupted BIOS, right? So my schedule has been very tight. So what I need to do is to get to the market, get the exact BIOS, unsolder it, replace it, or flash it, or get a new motherboard altogether. So because without this guy, your system is not going to boot. Along with the post, BIOS also identifies which hard drives are available, which drives are bootable, how the memory is configured, because that's what now does all of those tests. When your system boots up, it tells you, you can be able to tell how much RAM you have, how much hard disks you have, how much. It's the guy that does all of those stuff. So this is what the CMOS battery looks like. For instance, your system, if your battery fails, most important settings are going to be lost. The configurations you have on your BIOS is going to be lost. Your date and time is going to be lost. If you see a system that does not save date, right, it then means the BIOS is bad. Rather, the CMOS battery is bad. So it's complementary metal oxide semiconductor, just like a battery. It's a small chip. It saves all of those settings. In your wristwatch, in your clock, in most devices, you have a CMOS battery. People call it battery. Yes, it works like a battery, but most of the times it works not just like a battery. It does more for a CMOS battery. What does it do? It saves the motherboard settings. Your wristwatch. If your wristwatch, the battery or the CMOS start getting bad, what happens is that your time starts delaying. Same thing for your laptop, for your desktop. So that's the guy. So if you see any system that you set your time and you find out that after 12 hours it's still the same thing, or you boot up, you still see some messages coming like as if you're configuring the system for the first time, it then means that your CMOS is bad. So you just open up less than $1, right? Or less than 200-300 naira, you could get a replacement and just snap it in. You pull it up and snap it in, and you're good. I'm saying something here. If the computer time and date are incorrect, it's the CMOS battery is bad. It's getting very low. Yes, correct. UEFI. So UEFI is a small reset, right? So most computers today run Unified Extensible Firmware Interface. All new computers come with UEFI, which provides additional features to your BIOS. It can run on 32, it can run on 64 bits. Okay, so there's a lab, you boot up a computer, able to enter into your BIOS, and most systems are going to have you enter into BIOS by either F2 or F10. So once your system is booting up, press F2, F10. If you want to try this with your laptop, you could just Google and say Toshiba or Dell HP15, enter BIOS. Put that on Google, it's going to tell you the right key, the exact key to press. Most laptops have different configurations. Most desktops have different configurations, different ways you could enter into BIOS. Some is control F1, some is control F2, some is alternate Ds, some is just F10, some is F whatever. But mostly F2 or F10, you get into BIOS. Okay, security. Yes, there are several things you could do. You could add security to it. You see some people, once you just start up your system, that's what they call the BIOS lock, right? If you set up some things on your system and you don't want somebody to be able to do any changes to that, I'm talking about the interface you have before even your desktop, before you enter your password for your Windows password. That's what we're discussing. We're discussing from your initial boot up, right? If you don't want the person to have access to even your operating system right from the motherboard you want to password, so it's actually the BIOS password that you password. You can also update firmware. Okay, there's a lab installing Windows. So there are different ways to install Windows. You could use the evaluation copy. You could buy a license copy if you need one. You could let me know. We resell antivirus, malware, anti-malware, Windows, OEM licenses, several types of licenses. If you need them in thousands, we are accredited resellers. We could have that sent to you, right? But just for a trial, you could download the evaluation copy, right, from the TechNet, from the Windows side, and you could make that installation. So in that lab, you have instructions for that. So don't forget that once we're done with our 14 modules, we're not going to start considering most of our labs. So we want to be sure that we have the theoretical and some of the video-based hands-on, right? Before we now start getting our hands dirty. But it doesn't stop you from trying any of those things I've told you to try out. Okay, electrical power. So I'll be some physics. If you don't have background in physics or mathematics, you should still be fine. This is just some very basic electricity. Voltage. What is voltage, right? Well, let's first understand what current is. So current is measure of electrons, right? So that charge, when you charge your phone, you charge your laptop, so you're talking about current, because that's how electricity is stored. It's stored in amperes. Your batteries, your inverter batteries, your laptop batteries, your any of your batteries, electricity is stored in that format. The measure of work required to move a charge from point A to point B, that's voltage. So high voltage will move charge faster. Resistance, we call that the opposition to the flow of current. Then of course power, which is in watts, is measure of work required to move electrons through a circuit multiplied by the number of electrons going through a circuit per second. Put it very simple. This is watt. And watt is what? Power. And what is power? I times V. Very simple. The electrical system power is equal to the voltage multiplied by the current. So if you know this PI, and that's what we call the Ohm's law. Back then in physics days, it's defined here by saying the Ohm's law expresses how voltage is equal to the current multiplied by the resistance. This is a very simple definition. If I want to make it a little bit more simpler, I would say voltage is directly proportional to current. I also say voltage is inversely proportional to resistance. So V directly proportional to current and V inversely proportional to resistance. So you have something like this: V directly proportional to I and V inversely 1 over R. You don't have it here, but you could take this and write out in your notes, right? What that means is that as your current, your voltage is increasing, your current is increasing. So if I have a chart this way, if I have a chart and I have voltage, I have current. So it goes like this. My chart is going to go like this. As this is increasing, this is going to be increasing. Just like population, year, and population for most countries, as you have 1991, 92, 93, 94, 95, 96, up to 2021. If you have 5 million, 10 million, if you draw it, you have a straight line this way. So as this is increasing, this is increasing. That's how voltage is directly proportional to current. But for resistance, because resistance is the opposition to flow of current, so they are inversely proportional. So as one is increasing, the other is increasing. Take for instance, if you have a wire, a large wire is going to have low resistance because it will allow enough of voltage to flow through it. So the more voltage that can flow through an appliance, the less the resistance, because resistance is actually opposition to flow of current. So we don't want current to pass through. So the bigger the wire, the what? The less the resistance. So the more tiny wire you have, the more how tiny your wire is. It's going to have high resistance because more tiny wire is not going to allow electricity to go to flow through it. So if electricity does not flow through it, it then means it has a high resistance to flow of electricity. So more tiny wires, if you put large electricity through them, because of the opposition, it's going to blow up. So that explains some basic electricity for you. The power supply. Don't forget when we looked at module 2, we saw that you have the, different power supplies. They could range from, let's say, 125 watt. When we talk about power, we talk about watts. Don't forget power, we talk about watts, right? So work done, moving electronics from one point to the other, or just put it at VI, voltage times current. Okay, so this can come in 120 watts, 200 watts, 300 watts, 400 watts, depending. The bigger the motherboard, the bigger the power pack. But we're talking about voltage here. We're done with power. That was the last module. In different countries, in Germany, US, Africa, Europe, they use different type of voltage in transmission. I mean, from transmission station to where you have delivery in homes in factories. So most European countries, in the US, they use this low voltage system, 110 maximum up to 150. In Africa, most African countries, especially in Nigeria, we use 220 up to 230 to 40. So our transformer, from what does the transformer do? It steps down or it steps up. So that's what the transformer does. Just transform the voltage into usable form. So what happens is that when our transformer gets power from the grid, from the power station, it steps it down from maybe from 33 kVA to 11 kVA, from 11 kVA. kVA is kilo voltage, right? So I have kilo is times 1000. So from 32 kVA to what was it called, 11 kVA, from 11 kVA you now have a transformer in your house that now steps it down. Once it steps it down, of course, in the way transmission is done, especially in Africa or Nigeria, you see your high tensions or your transmission tensions, they go kind of horizontal. You see three pairs of wire going horizontally. At the point when they are now stepped down to some substation, they now become kind of vertical. So you now have three lines vertically. Then what am I saying? Okay, let me start afresh. Yes, you have it horizontal. After horizontal, you now have it horizontal, but now slanting, like as if you're just pointing at something. If you put out your three fingers, you're pointing at something. So at first, you have something like this. You have okay. I think let me do a little drawing here. Insert. Uh, what can draw me a line? Okay, let me draw. Okay, draw. Okay, maybe at first you have something like this, right? You have something like this. So at first, okay, I think I'm not able to do that very well, except if I get to paint. I'll just try my best to try to explain what I'm trying to say. Okay, for instance, at first you have lines like this on top, right? As if you're putting your hand on top of somebody's head, three fingers on top of somebody's head. So your line goes that way. Once the other step down, your hands now go vertically, as if you are pointing three fingers to the person. So that's how you have your transmissions. After that is done, it's now step down your transformer, it now enters into your house. At the point it's entering your house, in Africa, it's 220 voltage. At times, if you have high voltage, you can have up to 240. So the point I'm trying to make is that most appliances here in Africa use this as their weight ratings. Whereas in Europe, in the US, you have this as their rating. So if you bring an appliance from Europe and you connect it to 220, it's going to blow up. That has happened to me like once or twice. A computer, I think that back then in 27 or 25 or so, that was about 10, it's up to 10 years, 7, 8, 9, 10, 11, 10, 13, 14, 15, 17, 18, 19, 20, 21. That was about 14 years ago. So it blew up, right? So what do you need? You need a step down. So, but some power packs have you're able to have a regulator, right? So you can switch to 220 or you can switch to 110, right? So if you are sure it is written here 110 and you're in a place where the voltage is 220, you must have a step-up transformer. A step-up transformer, you connect this one, the transformer is there, then you connect your appliance here. So it takes in the what's it called, the 220, and he steps it down so that this guy can consume it. But most of the time these days, you have appliances, TV sets, computers, they now have 110 to 220. That's even when you have low voltage transmission. What happens? Those appliances still work seamlessly. So even when you have low voltages, it still work very well. But you have some power packs that can actually do dual voltage supply. They could detect whichever, and within them they have that step up, step down, whatever. Okay, Ops law, we've talked about that. So there are different types of power fluctuation. So when you have the blackout, you have complete loss. If you have a brownout, reduced voltage, right? Noise, inference from generators or lightnings, right? Spike, when you have sudden increase in voltage, power surge, when you have increase in voltage above the normal flow of electricity. So you need some kind of gadgets to help protect against all of that. So these are protection devices, such protectors, UPS. So most UPS and such protectors or standby power supply is good. They're going to help you do some of these surges and make sure that you don't affect your appliances. Okay, advanced computer functionality. Let's look at CPU architecture. So you have the RISC and the CISC. Just tells you how the program is being stored, the instructions. This is just the internal workings of your CPU. Same thing with this, and they come in different sizes. Back then, computers used to have uh, in less than megahertz. I could still remember the Pentium 1 systems, they had less than one gigahertz. So they're in megahertz, right? Their speed is in megahertz. So the speed of a CPU is rated in cycles per second. How fast can it go? How fast can it process? Right? So megahertz. So once it gets to a billion, it becomes gigahertz. So most computers these days are in gigahertz, right? Okay, what else is very critical and important here? So we have overclocking. So most computer motherboards are going to be able to allow you to do overclocking, but it's very dangerous. Because if you, it's just like tell a child, walk from here to another country, another state. But you could do overclocking, right? Your computer can allow you to do overclocking to a particular speed. So throttling, that's the opposite of overclocking. So you're just trying to say, okay, can in my BIOS settings, can I make it work a little bit faster, right, to improve the performance? There's also to call CPU virtualization. Not all CPUs can virtualize. Not all. I'm sure in your first cybersecurity course, you were asked to install Kali Linux, you were asked to install, let's say, Ubuntu, you were asked to virtualize. So virtualization is you having an operating system as a child inside of another operating system running parallel, right? So virtualization is a hardware feature supported by most processors. So you have two processor giants, AMD and Intel. So you have a PC, like I'm running on Windows 10, I have my system here. I also have Oracle VirtualBox. These are virtualization softwares. I also have VMware virtualization softwares. Once you install that hypervisor, once you install that software, what happens is that you can now add other operating system on top of that operating system. It is going to give them RAM size, it's going to give each of them, so you're not like you have 4 5 systems. So the cybersecurity expert, that's why you need up to at least 8 gig RAM minimum. You could go up to 16 better, so that you could do some of these things and still run at a very fast speed. So you have what they call the multiprocessor. So just because of we need systems that are going to run very fast, these days processors don't come just in single core. So they have dual core, triple core, quad core, hexa core, octa core. Just tells us the number of processors that can work jointly to increase our speed. Okay, cooling. We've talked about cooling in our previous model, just things that will help for airflow. I've explained all this. Then RAID concepts. This has to do with your disks, right? So especially in large scale data centers, that's when you have this being applied. So you have mirror disks. That sometimes you need to understand stripping, mirroring, parity, and double parity. So parity has to do with you checking for faults. Most of these hard disks, you ask yourself, even for a flash drive, you start a flash drive into your system, your flash drive is going to tell you that it looks like an error wherever, please check this and blah blah blah. For your hard disk, even for your system, it don't shut down properly, it's going to boot up and tell you please check this or run repair wherever. These are concepts that help your computer to operate maximally. Legacy. Why do you call it legacy? Things that are not in vogue, things that are not readily used now. Back then, this is the mouse. It's called the PS2. This is the keyboard. It's normally purple. It's normally gray. This is for audio. This is for printers most times, right? So you call them parallel. Whereas this you call it serial. This is for a Cisco switch or some devices, right? This is VGA. This is 15 pins. This is DB9. If you see 5 pins up, 4 pin down. Am I counting properly? Yes, correct. 5 pin up, 4 pin down. So that's 9. So this is called the DB9 port. This is a female port. I will all know females, they always collect. Males they give. So anything that's collecting is a female. Anything that is giving is a male. So this is female, 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 female. Right? All of this is female. So the guys that is entering here, they are what? The male ports. Okay, serial, printers, scanners, modems, console connections to network devices. So Cisco switches, right? Later on in some of these modules, later on in the course, I'm going to present you. I have in the office here, I have some Cisco switches, Cisco routers. I'm going to show you them and present to you physically. But the LMS labs will always suffice for you because you're going to see all of those guys. VGA, so this 15 pins is always 1, 5, 5, 5, 15 pins. So this is DVI. Most of these things were used then with respect to videos. All of these things, videos, HDMI. But this is more recent now. VGA, some systems still have VGA. You rarely see this again. You rarely see this again. So all these are for what? For display. USB, right? So you have the different types of USBs. SATA, I told you earlier when I was explaining PC components. So this is a hard disk. If you bring it out, if you have an external hard disk adapter, like I have one just by my side here, if you open it, this is what you go to see inside. So this is data, this is power, right? So don't forget that. For instance, your SATA cable, it's different this way, but it doesn't need more than 5 volts. This is actually rated 5 volts because your USB gives you 5 volts. That's why your USB is going to charge your phone, right? That's a USB. There are some external CD-ROMs. Your USB, it will power them, right? Because the USB have two of this guy is positive, negative, data, ground. This cable is like this. So whereas this is data, this will transmit data. So if you connect only this, it's not going to power it up. So it's not going to spin. If you connect only this, it will power it up. You cannot transfer data. Okay, twisted pair. So this is networking now. We'll talk about networking later on. I think there's a module that just concentrates on networking. So we're going to look at some of this what we call unshielded twisted pair. Twisted pair, RJ45. So this is for Ethernet. This is for phone, telephone. Why is it twisted? Like this is Ethernet, right? This is RJ11. This is 45. So this is what this connector is what you call 11. Right? This connector rather is what you call 45. This connector is what you call 11. So this is for telephone. If you check the back of your modem, if you check the back of your maybe your router, if you check the back of your switches, check the back of your what's it called? You're going to see a small whatever. That's for telephone. Because back then most telephones line they could do fax, they could do internet, a landline. You see these two ports. So this is normally used on PCs. So older PCs still have this, but rarely do you see that again. So you call twisted because they are always twisted, and that's for noise reduction. Actually, we're going to talk about that later on when we talk about networking. So you have what's it called? Green and green white, blue, blue white, yellow, yellow white, brown, brown white. So we'll talk about this later on and explain in more detail. So you have different connectors. So you have coaxial cable, your RJ6, RJ50. This 59 is normally used for CCTV. Like I have some CCTV, I have some cables, I have this in quite some length, right? Coaxial for transmission, right? Your TV set, your DSTV, your GoTV, the money use coaxial. So BNC is that connector, this guy here, right? For CCTV installations, analog, 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 analog. For digital, for IP cameras, you use this, you use Ethernet. For analog cameras, you use BNC. Okay, serial small computer system interfaces. So that's this guy. Older printers, that's what they use, right? Older printers, you rarely will find this again. This is called your IDE cables. This is for floppy. This is for, I think, for hard disks and for CD-ROM. It's a little bit much smaller. Okay, monitors. So your monitor have different characteristics. Your screen resolution, your monitor resolution, your native mode. These are very, very basic things you could read up, you could always understand. So of course, these are some terms you should familiarize yourself with. Yes, this is very important. CGA, VGA. YouTube, for instance, just upgraded to a little bit more than this, 4K. If you're on YouTube, if you're streaming a video of this video, if you're watching it from YouTube, you see that your resolution tells how much pixels is going to be rendered at per time within your frame. That's it, pixel. A tiny dot capable of displaying red, green, blue, RGB. So if you combine RGB, you have the full color. You combine it in different lengths. So RGB is going to be in hex format, is going to be something like this. FF, FF, FF. So this is like white, right? For graphic designers, web developers, you understand this. So this, because it's hex, so it goes from, I think, 0 to up to from 0 to 9, from A B C D up to F, right? A B C D E F. So hex, you don't go more than 6. So when you have FF, that's to say red is complete 100%, green FF. So if you start, I think I can see this a moment. More text fill, color, more colors, also custom. Yes, this is it. RGB. So if I say FF, see, as I change this, okay, I think this can go up to 255. I put this at 0, so it can go up to 255. So this is the RGB format. You can have the HSL format. If it's RGB format, I have red. Red is complete. Green, no part of green. So when you mix these three primary colors, you could have white. So if I have 255 of this, 255 of this, so it then means that if I have red and green in full proportion, I have yellow. Yes, if I have 255 of this, I have white. So three colors mixed together, I have white. I know it sounds kind of funny, yes, but I need to let you understand some of these things so that okay, let me take this off and let us get back to business. So pixel, I was talking about your colors, right? Display, because how much, so if I have up to these resolutions, that means I could have compactment of more colors within a small, that makes my picture clarity very sharp. So the bigger the resolution, the better for you. Yes, you could use multiple monitors. That's why you could do a presentation to your system. Use your Windows P, right? And you can send to another monitor. Configurations. So some basic configurations you could do if you need to upgrade. Very importantly, know what you are changing. Know what you're changing. Inspect what you want to replace. Then it must fit into the old case. Then just go pick up something and you replace. Look at this fan, very huge. The question is that can it fit into the case that this you have this motherboard in? Okay, if you're going to upgrade, this is what you're going to do. You have to record how the power supply case, fan and case attached to the old motherboard. Until you do this in practice over time, it becomes very, very simple, right? So you disconnect this, you record how. Normally, when I do this kind of things, I have a flat surface like we saw in the previous model. You pick out things and you're able to understand where you pick them from, and when you're replacing, you replace intact. If you do this 1, 2, 3 times, you should be very familiar and you won't have any issues. If you want to upgrade your CPU, like I said earlier on, it's possible you can upgrade. You just take off the heatsink, There's a lever here. You could pull this up. This guy is going to flip open. You take it off, bring the new one, you clip it back, put back your heatsink, and you're done. Okay, storage upgrade. Yes, hard disks. I have a 60 gig hard disk. I have a 100 hard disks. I need 500 hard disks. It's very simple. Open up the case, take this guy off, bring the back in, the other guy in. This is the data. Then look for the supply. You attach it, and you're done. Yes, peripherals. So printers, speakers, mouse, keyboards, they are all called peripherals. So you could always upgrade them. You could remove what you don't like and put up something new. Yes, power upgrade. Power pack might be affected. But make sure that you like see this guy now goes to the motherboard. This guy goes to a section in the motherboard. This guy goes to see this is a very recent power pack. This size goes to the hard disk 1, hard disk 2. So you could have up to 2, 3 hard disks on your system instead of having partitions. This guy allows you to have more than one hard disk. You could get to the market and also buy splitters. So if you connect one here, it could have up to 2, 3. That makes you be able to scale up your system. There's a lab, research a hardware upgrade. In this lab, you get information about hardware components so you can upgrade your customer hardware so that they can play advanced video games. So what do we need? We need a higher processor, we need a higher RAM, we need a higher video card through PCI upgrade, right? That's what we need. So we have what they call the thick client and the thin client. So the thick client is like your own system, the standalone most systems. But thin clients in most CBT centers, where you're going to be doing deployment in large scale, 500 systems, 200 systems, you don't want to have individual systems on their own. You just want to have small systems that are not networked together. You see this in most exam centers, small systems, but they all have a central operating server, right? So you have what they call the network attached storage. So it's just simply a hard disk that you can plug to your network and everyone on the network can see it. Some of them can even have wireless. So you could just connect to it and you can have access to the hard disk. Your environment is very important. Don't trash things. This is um, um, a desktop screen, paint, brush, battery. Normally we say batteries are field replaceable units. Okay, yes, so it's here. So I call it field replaceable units. You don't repair it. It's bad, it's bad. Throw it away, get a new one. Field replaceable items. Toners, right? It's bad, throw it away. Some people attempt to fill it, they get success doing that. After some time, the system gets bad. So you want to dispose properly, right? And follow the recycle instructions in the manual in the containers of whichever of the items. Older systems have the bigger ones, what we call the cathode tube, that looks like this, very big, right? We call it the guy with the big stomach. It consumes high power, so this consumes less power. So you should dispose of properly. And most of them have data sheets to tell you by the OSHA standard, tell you how to properly dispose these things. Okay, we're done for module 3. Congratulations. Chapter summary. We've learned about the BIOS, the UEFI settings, talked about power, the Ohm's law, and the rest. We talked about computer functionality, monitor characteristics, and how do you protect your environment. Thank you very much for listening. See you in module 4.